Hello everyone, I'm Renata Seki, and today I'm going to show you how to use CURATOR. CURATOR is a batch active learning workflow that was developed at my group at DTU in the Department of Energy Conversion and Storage. This tutorial is going to be only about how to use it in practice. We are not explaining any theory behind it. However, we have first a tutorial paper that you can find open access on in this website, and upcoming there's going to be also another longer paper for like explaining even better and more in depth what we are doing, what we are doing with it for this workflow. So we are going to put like a link in which you can download some files, some files, and the form of this tutorial is going to be a collab notebook. So you are going to download this folder and then like upload it on your Google Drive. And now I can show you. So if we go in a second, here these are the files you will display. One of them that is called Tutorial Curator, is an IPython notebook, and if you click it, it's gonna be our commented tutorial. First, in order to run Curator, you need GPUs, and this is also the reason why we are using Colab. And this is such a nice tool for this. And you can change your runtime, because I don't think by default it's going to be with GPUs. Change your runtime to the GPUs by going into the menu, runtime, change runtime type. And here, like whichever version you have, you're at least gonna have like these default GPUs. Save. And now we can start. First, I wanted to tell you what we are going to learn in this tutorial. And first is how to set up the workflow, because there are some packages you're gonna need, and how to run it, and how to understand the outcomes, how the output, the form of the output, and how it is organized. And okay, so we will start. First thing we are installing is GPO. GPO is a DFT Python code that is open source, and so we are using that in this version in order to make our workflow accessible to everybody. We have first to clone the directory, so we run this cell, and takes a tiny bit. Then in this cell we wrote capture, because the output is like it's a bit long, and we don't want it, just in order to you to understand better what we are doing. Of course, if you have a bug, or if you want to understand exactly how the program is installed, just take out this line capture in these cells. Then do get upgrade, update, and this. All right, and then like we are installing GPO, and yes, after this, what we are going to install is some dataset that are needed by GPO itself, and we are going to make. Okay, this is taking a bit for the installation, and practically here I'm okay, done. We make a directory that's called GPO setups, and then we just say this GPO install data. But you can go here, there is the link, you can go here directly, and you can check which kind of why are we more in detail what is that we are doing here. Just when you're on your notebook here, at a certain point, it will ask you like if you want to register this to the this part to the GPO setups. Just say yes. Okay, done. Now that we installed GPO, we have to restart the runtime. There are different ways you can do it. You can do it like simply like runtime, restart runtime, or you can just like kill the process from here. That like is the same. It's gonna tell us, and then like we check that our GPO and the ASE atomic simulation environments are running. It's like just for. Then you can also check your GPO version here. Now, new step. This was the installation of GPO. Now we install really like our workflow code of Curator. So we install first TML. Then we want to install PyTorch. Sometimes when you don't, so since there are like different options for PyTorch, you're not sure like which kind of GPUs do you have, which kind of Python do you, like which version of Python do you have. It's a bit difficult to install PyTorch, or like it can be like you have some errors and you don't know why. So like a quick fix is that you just print the version of like your GPUs and your Python. So here you can say like we have like CUDA 11.8 and then a Python 3.10.12. So you can just go on the PyTorch website, then like it's asking us, of course, and just like take the different options. What we are doing here is just taking this line and then like copy pasting this into the tutorial. So yeah, here we are. So that's what I did here. And then after PyTorch, we need to install ASAP3. ASAP3 is it's a calculator for doing like a large scale molecular dynamics, and with atomic simulation environment. We just installed this because it's between the dependencies. And now is the interesting part. So when you want to perform active learning, it's very difficult because you have like a lot of files. Imagine like you have like a lot of training, and then like you have a lot of like, and after that you want to run production of molecular dynamics, and after that you want to do like the select some of the frames for your active learning process. But like this is very like it is easily a lot of files you have to keep track with. And some files depend on some other ones. So what we do is that we install MyQ, and MyQ is a frontend that can help us in managing like the tasks that are in our workflow. So MyQ will like start a file, like submit a file after one other is done and not before, and so on. And MyQ can be run in parallel. So sorry, MyQ can be run in forced alarm systems, but it can also be run in local. So on your own machine, or as in here, we are running MyQ in Colab. Now that everything is done, we have to we have to give the permission for for seeing like the files in our drive. And we want also to change our working directory to be this one, to be the one in which there is our tutorial. As you can see, like here, I'm just like listing the files that I have in my directory, and here you can see these are like the workflow files, and for Pale, and here are there are other files we need for the submission of each step of the workflow. Then we need to initialize my queue and to guess the configuration. This is maybe like guessing the configuration is maybe not relevant here, also because I've already told you we're running my queue in local. But if you are not sure or of the setup of your machine or of your resources, is actually a good it's actually a good command to be sure also of the syntax or to write everything. And here we just write a configuration file into the myqueue folder. In this myqueue folder, then there are going to be also other files that are stating the state of our workflow. So if the file already run and run successfully, or if some files crash it, and so and so it cannot be run anymore. Then so if you are starting, so this cell is it's only if you are starting the workflow multiple times, then maybe you have some files that you don't need anymore or so on, but they're still there from the previous that have been generated for the previous runs. In this case, this cell is done to prevent you to have them, and so to make it easy for you to run the workflow multiple times. Of course, keep track of your file, because else you delete here. You just restart from zero the myqueue. So here is our pretty figure of that we also have in the tutorial paper of what our workflow does. So step one is the dataset that can be molecules, boxes, so some kind of electrolyte, which is water, an interface as it is here. And then second step is gonna be the training of our workflow, and that we do with pain in this case, which is a kind of neural network, a message passing neural network. Then there is the production. In this case is a molecular dynamic simulation. And then we select some of the, we have some algorithms that you can also tune and choose depending on what exactly you want in your performance. And you can select from your simulation which are the most interesting frames, or the frames that your model know the less. And then we just do what is called the DFT labeling. The DFT labeling is practically that this selective file will be the structure from this selective file will be an input of a DFT calculation, and this with the same level of theory of step one, so that we can add these files to the initial data set and retrain for multiple times. And myqueue, as I was explaining before, is managing all these tasks, so that we can run this for 20 iterations for multiple days, weeks, and we don't have to worry about that, about submitting files. Now we have to change something. So here, if you go on the left, there is my drive tutorial video. That is going to be, of course, for you, it's going to be different which file do you have, but we need to change the configuration file. This is practically the file in which we set up our workflow with all the parameters. If you want to go more into that, or with the description of them, this is available in the tutorial paper we did, and also it will be available also in the longer workflow paper. What you are going to change are the path file at 3 points. Always start with content drive, and this is because this is your complete path. Else you can run into some mistakes because it simply doesn't find the file. Then put the path to this file. It's called forwaters.try, which is a trajectory file, which is our initial data set. with a simulation with 4 water molecules, of course. So first data set this. Then second place in which you have to go is initial trajectory for the MD run, so like the molecular dynamic production after the training. Put the same file, or in this case we put the same file, the same path for the same file. And then for the selection run, we have to say which is the training set. And just change this path, so 1, 2, and 3. Else it will not change your you will not find the file for the workflow. Then here is the number of epochs you want to train with. Now this is just a tutorial, so we have 2000. Of course, if you have more resources, or if you're like running on an HPC, of course change it to a longer higher number. Yeah. Here we are training two models, one with 108 nodes and the other one with 112. If you want to add more nodes, more models to the ensemble, just write, for example, here something like 116 nodes and so on, like keeping the same structure we had here. Yeah, but like for running that, for running this tutorial, you just have to change the path of your file in 3 points. Okay, so now it's done. We can visualize the files in our directory now. Yeah, and here there is like the GPO configuration. We can ignore now, or we can also do this. Dear first, dear first, and so that we have first all the directories. We start from the bottom. This is us. This in our notebook. Then there are like these files. That's the trajectory file, and there are 2 YAML files. This configuration file and this labeling configuration. And here you can find like the labeling configuration for GPO. And so if you want to, in case you want to change it, but then if you want to run different dataset with another level of theory, you can change it. Here then there are like the pain model with all the files that we need for the machine learning. And here just like some tool for GPO. So it's not important for us in this moment. Now we will run the workflow. I make it bigger again. So we are running the workflow, and it's this cell. This cell has 3 parts, can be understood in 3 parts again. The first part is your Python path. Every time you want your Python to know all the packages and everything you installed, and for your workflow. So to make sure that your Python path doesn't change, these lines are for making sure that the Python path you are running, each file in each directory for this workflow is the path that with everything that we just installed. In this case, just run this. The second part is the start of like the MyQ local server. Just don't worry about that. It's just a Python command for like running MyQ in local. So like to say MyQ, look, the configuration is like this, and your resources are the one that are the one that are in this. Then there is like the proper command for the workflow, which is myq command workflow run flow.py, and this is like force -t. I will explain in a minute what this means. Okay, so then like let's run, and it will tell us, yeah, here you can see there is one file is running. here we can, with the command myqls, you can monitor. Don't touch this anymore because then your files are running. With the command myqls, you can monitor at every time what is the state of your workflow. Like here, the train iteration 0 of model with 112 nodes and 3 layers is running, and this is the path of that. You can see that now, after like we run the workflow command, we are going to have a different we are going to have like new directories, and these are like the one we had before. Then we have a directory for the training, and like either iteration 0, iteration 1, and then we have like md, iteration 0, iteration 1, select, and so on. If you go into that, you can also check it from here. As you can see here, for example, now I go in the training, iteration 0, my model, 100 nodes, and here I'm going to have always two files. One is an output file, the other one is an error file. If something goes wrong, check the error file, and you can say, like, if some task you see from here is failed, just go and check your error file so that you can, for debugging purposes, you can check why something crashed. Then, now I promise I'm going to explain you what force and what -t means. Force, minus force means that I want, in case I am running for multiple times, and something crashes, so some tasks are cancelled or they are failed, and I want to resubmit the same workflow because maybe I changed something. Anyway, I want to resubmit the same workflow. Then I say force, which means, okay, resubmit this task even if they have been cancelled before. -t is like for tracing the errors, if you have any. Alright, so now you just have to wait, and it will go for, here you will see the age of your calculation and the time. Here's how the directory looks like, and what I want to show you now is how, so we can talk a bit about the differences that we have between like running this in local and running this in HPC. I don't know which kind of research you do. In my group, we study catalytic processes, and usually we use these models for like bigger systems, and so we use, of course, a cluster for doing this. And we run this workflow on Niflheim, which is our cluster at DTU Energy. And as you can see here, we have the name of the resources we are running. So in the configuration file, we are just writing that the node name, that a certain thing, for example, the train has to submit task 2, and this is like the time, the maximum time, and this is the amount of resources. And as you can see here, I am running multiple multiple models in my trajectory for my workflow, and and I also can run like also in parallel. Here instead, I figured that it was easier to run only sequential, like in not to run in parallel. So we have like one node each time, and also our resources, of course, they're not gonna be 7 days. I guess depending on your collab setup, they're around, or how much you use it, they can be like I think the maximum is around 20 hours, something like this. But it just in order to show you how it looks like. So we run it again, and as you can see, first model is done, and the other one, and after that the other one is running. Another difference is that here in this workflow you are running in your train models in sequentially. So after one is done, you can only run one task at a time. So after one task is done, you will run the other one with the same priority. If you are running, for example, in an HPC, you will have also the possibility to run multiple tasks at the same time. And now we have to stop. All right. So now, as you can see, after a bit, like depending on the resources available at the moment, you will have like it looks like this. Like some tasks will be done and some not. And some are still running. If you look at the directory, as I was mentioning before, we have like the new thing, the new directories. Now we want to start visualizing our output. How we can do that? For example, like we are doing like we are producing like a molecular dynamics simulation. So we can just have a look at that, no? So we install MGL and once it's done, we have to enable collab to like doing like showing some kind of output. And then what we will do is to view it. I will just check in like the length of the simulation before, and this is like the path to our simulation. It's always like the path is always standard, like the order of the directory is always standard. So you actually like unless like you change the name of your system and you have like water, but like I don't know, hide on something whatsoever, then like you might have that. So we run this cell and like here on this, and then as you can see, we have our modern molecules. Now it's a fairly small simulation, I guess, but like you can see that they are moving. And yeah, we can also move these. And okay, wall size, you can also make them differently. I think it's very funny. And you can check what's happening in the simulation. Like for example, like now you can see we are the first iteration because like the workflow doesn't really know what to do with the hydrogen, or like it's not like a long simulation of a super well-trained model, but in it's training, it's in the process of training. It needs more train, need more epochs, and so and like I think maybe a bit better parameters. But we can also change this, and I think we can also change the ball size. It's funny. Yeah. And other things, yeah, our looks on HPC will look like this. So we have like things in parallel. Anytime you can like can also stop it. All right, anytime you can check how is your workflow doing. And let's say something crashes, we have a failed task or something has been cancelled, then like you can run this command here for like canceling, but like really read the MQ documentation for this, all right? And then you can go through all the files here and check all the for all the iterations, for all the folders, and check what's happening, and then like you can use them for your analysis. Then as I say, you can modify the configuration file, and I think this is like basically how we use this workflow. And I hope that you like our tutorial, and if you have questions you can write in the comments, or you can write us in email. We invite you to read the papers if you have other questions, and because there is a bit more explained in detail. And yeah, thank you for your attention.